Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. It has been one of the greatest surprises of the space age. Powerful magnetic fields pervade the cosmos. Mainstream astronomy and astrophysicists do indeed acknowledge pervasive cosmic magnetism, but they did not predict it, and the realization has come begrudgingly. Some perspective into these ideas can be gleaned from an early online NASA feature from the 1990s, which asked the question, do magnetic fields exist throughout space? It states, on the cosmological scale, there is no data to suggest that magnetic fields are present. They certainly are not important in the dynamics of the universe for any reasonable range of field strengths consistent with present observational constraints. Of course, like countless other consensus ideas in cosmology, discovery has shown no regard for these commonly held beliefs. The now unavoidable problem of cosmic magnetism in astronomy is acknowledged in a 2011 Universe Today piece, which states, the mention of cosmic scale magnetic fields is still likely to be met with an uncomfortable silence in some astronomical circles. And after a bit of foot shuffling and throat clearing, the discussion will be moved on to safer topics. But look, they're out there. They probably do play a role in galaxy evolution, if not galaxy formation, and are certainly a feature of the interstellar medium and the intergalactic medium. The reason magnetic fields in space are so problematic for standard gravity-only cosmology is self-evident. Possibly apart from bar magnets, only electric currents produce magnetic fields. And for many decades, plasma cosmology has proposed that electric currents over vast cosmic distances play a significant role in the formation and evolution of stars and galaxies. Plasma cosmology predicted that stars would be found to form along vast networks of filaments, like pearls on a string, an outrageous prediction that discovery confirmed. The plasma scientist Dr. Anthony Peratt of Los Alamos Laboratories demonstrated experimentally that galactic structures can evolve under the influence of electric currents. Through what is known as the pinch effect, parallel currents converge to produce structures identical in form to spiral galaxies. And it was well over a century ago that Norwegian experimentalist Christian Birkeland predicted that electric currents from the sun were the cause of our planet's auroras, a claim that astronomers almost universally rejected until it was finally proved in the 1970s. In fact, with no official pronouncement, within some circles in the space sciences, the recognition and study of electric currents in space appears to be slowly growing. Consider the recent article published by the American Geophysical Union's Earth and Space Science News, entitled Electric Currents in Outer Space Run the Show, which is a summary of the new book, Electric Currents in Geospace and Beyond. The article states bluntly, it is now understood that outer space is fundamentally electrical in nature, a type of statement that critics of the electric universe have long decried as preposterous and pseudoscientific. On the extremely challenging task of observing and measuring electric currents, the authors state, since electric currents are comprised of moving charged particles such as ions and electrons, the most direct way to measure currents is by probing and counting the individual particles. Highly tuned instruments that fly on board satellites do exactly that. While particle counting is quite challenging, as one might expect, one can also make use of the fact that electric currents generate a magnetic field around them, which in turn can be measured more easily by instruments called magnetometers. From these magnetic fields, one can then infer, using Maxwell's equations, the underlying currents. But the inference of underlying electric currents as the cause of magnetic fields in space remains a shockingly rare practice in the astronomical literature. Thus, the processes astronomers and astrophysicists have invented to try to explain cosmic magnetic fields have only grown increasingly weird, encountering greater and greater problems in the face of ever finer technological data. Consider the discovery reported last year of galactic magnetic fields with, quote, astonishing order. As reported on phys.org, galactic magnetic fields are formed through numerous stellar explosions, the effects of which last for hundreds of millions of years. The energy bursts of all supernovas put together produce a galaxy's magnetic fields. Due to the fact that stellar explosions are chaotic processes, scientists had not expected them to generate a magnetic field with an orderly structure on a large scale. But this is exactly what they have now proved to be the case in several galaxies, even though the orderly structure did not manifest in every single object. The underlying mechanisms have not yet been fully understood. However, plasma cosmologists have hypothesized for decades that the quote, underlying mechanism is cosmic scale electric currents. More recently, in 2018, retired professor Dr. Donald Scott published his scientific model of galactic scale Birkeland currents as the cause of so-called anomalous stellar rotation profiles in galaxies, an anomaly that astronomers to this day believe can only be resolved by the influence of invisible dark matter. But as seen in this graph, the predicted stellar velocities based on Dr. Scott's model and the actual stellar velocities measured over nearly a century compare remarkably well. It is then not a coincidence that galaxies, like stars, form along vast networks of filaments, the form taken by the electric currents flowing through plasma which connect the bodies across cosmic distances. If electromagnetism rather than gravity is the organizational force creating structures in space, then both the imagined need for dark matter and the intractable problem of cosmic magnetic fields can finally be resolved. In our own celestial neighborhood, in the solar system, space scientists have had the opportunity to more directly test the long-held models of planetary magnetic fields. Let us consider NASA's recent Juno and Cassini missions to the gas giants Jupiter and Saturn, respectively. In both instances, the scientific data has shattered the belief that the source of the gas giants' respective magnetic fields is internal dynamos deep within the planets. As Juno principal investigator Scott Bolton stated of the findings at Jupiter, "I didn't expect all the theories to be wrong, but there's motion going on in the planet we did not anticipate." In a 2017 report, NewScientist.com outlined the conundrum as follows. Another shock is that Jupiter's huge magnetic field is even stronger and much more irregular than expected. However, rather than questioning the theoretical foundations that led to the predictive failures, the scientists proposed the ad hoc theory that Jupiter's hypothetical internal dynamo must simply be much closer to the planet's surface than was believed. The New Scientist report states, "The irregularity of the field so far is a sign that the dynamo driving it may originate higher up in Jupiter's interior, perhaps from a layer of metallic hydrogen. The dynamo driving the field is close to the surface over the entire planet, not buried deep within it like Earth's core. But the most important clue to the actual source of the planet's magnetic field is in the incredible electrical potentials at Jupiter that have now been confirmed by the Juno data. As described in an Earth and Space Science news report on Jupiter's incredibly powerful X-ray auroras, the data revealed particle signatures of parallel electrical fields over the poles of Jupiter that forced electrons near the poles upward, away from the planet, while protons and other ions moved downward into the atmosphere. This massive electric potential, upward of 1,000,000 electron volts, provides a possible explanation of where the X-ray auroras get their energy. In the electric universe, the assumption that all celestial bodies must carry no net charge cannot be correct, a fact that scientific discovery routinely affirms. Jupiter is an electrically charged rotating body, and any such body can produce its own magnetic field, with no need for internal dynamos. Electric currents flowing from the sun impinge on its poles, modifying its magnetic field, inducing its stupendous X-ray auroras, and powerfully influencing its superfast winds and cyclonic storms. As we've outlined previously many times, the aforementioned Dr. Scott recently published his mathematical modeling of the structure of a Birkeland current, which is identified visually as counter-rotating concentric cylinders. Critically, this counter-rotation is clearly seen at the poles of the gas giants Jupiter and Saturn. In fact, at Saturn, the crisis for the standard dynamo model of the planet's magnetic field is even more brazen. In 2018, Cassini scientists were astonished to discover that Saturn's magnetic field appears to have virtually no tilt. The crisis is explained as follows in a phys.org report. It was thought that magnetic fields around planets can only form when there is a discernible tilt between the rotation axis of the planet and the magnetic field axis. What the investigators actually found is that the tilt of Saturn's magnetic field is, quote, smaller than 1/100th of a degree. As principal investigator Michelle Doherty lamented, "It looks increasingly likely we will have to rethink the ways different kinds of planets can form magnetic fields." As we've also noted previously, in 2016, planetary scientists were amazed to discover that so-called magnetic ropes from the Sun stretch nearly 900 million miles to Saturn and interact with the gas giant in much the same way as they do with the Earth. We again note the aforementioned material published by the American Geophysical Union, which states that, quote, electric currents generate a magnetic field around them. From these magnetic fields, one can then infer using Maxwell's equations the underlying currents. Make no mistake, institutionalized science does now recognize the so-called magnetic universe. If and when space scientists begin widely inferring the electric currents that pervasive cosmic magnetism requires, it can only be inevitable they will reach the same conclusion as the aforementioned authors. That, quote, outer space is fundamentally electrical in nature.